Hello everyone, I am Professor Shivchilesh Dodge. Welcome you to the lecture series on Database Management System. We are discussing the module number 2 and the lecture number 28. So in the today's class, we are going to see regarding the specifying the basic constraints in the SQL, like specifying the attribute constraints and the attribute defaults, then specifying the key and the referential integrity constraints, then giving the names to the constraints, and finally we are going to see the specifying the constraints on tuples using the check. And we are also going to discuss about the schema change statements in SQL. So that is what we are going to see the drop command as well as the alter command. So at the end of this lecture, the student will have a better understanding of specifying the basic constraints in SQL as well as regarding the schema change statements like create, drop and the alter. So in the previous video, we have discussed about the SQL data definition and the data types. So in that, we have discussed about the schema and the catalog concepts. So schema is created by using the statement called create schema, and we also need to specify the schema name as well as the one who is authorized to access that schema. After in the schema, we are going to specify the table, constraints and domains, and possible values we are going to define it in this case of schema. Then after that, the table will be created by using the statement called create a table command. So in the create a table command, within the parenthesis we need to specify the attribute names, then the data types and optional constraints we can define. And the third one, we have discussed about the attribute data types and the domains in the SQL. So in the case of data types of the DBMS, we have discussed about the numeric, we have discussed about the date, time, then we also discussed about the storing the bit strings and the character strings, and we have discussed about the Boolean values also. These are the data types we have discussed in the previous video. Now, for specifying the attribute, so we can specify totally three types of, we can consider the unique is also one type of constraints. So totally we can specify four types of constraints on the attributes. So the first one is not null, and second one is the default value, third one is the check. So these are the mainly the three constraints we can specify on the attributes. Let us see in detail regarding the not null constraint. So the constraint not null may be specified if null is not permitted for a particular attribute. Consider that in a table, if there are 5 attributes, so the one attribute does not take null values. So does not take a null value means you can't leave them as the blank. In that time, you have to declare that column as the not null. So not null indicates that you must and should specify some value for that column. So this is always implicitly specified for the attributes that are a part of the primary key of each relation. So if I declared one column as the primary key, it means that obviously the primary key column will be always not null, and it is always, once again, it is also unique also. So it can be specified for any other attributes whose values are required not to be null. So if I declare primary key, by default it will be the not null. So there will be some columns which is not a primary key, then also you want it, it should not store the null value, then that time you declare it as a not null. For example, you can consider here, so we are creating the table called the department, having the attributes as the D name, D number, manager SSN and the manager started. Here in this case, you can consider here the D name and varchar is the data type we are specifying it. Here I am writing the constraints as the not null. So that means the department name you must and should specify it. Leaving it as a null is not possible if I define it as not null. Same way the department number also we are declare it as not null. So whereas the manager SSN and the manager start date, you are not mentioned it as not null. That means so these two columns can take the null values. Whereas for the D name and the D number, you must and should specify some values. Then the second type of constraint we are seeing is the default value constraints. So it is possible to define a default value for an attribute by appending the clause default, and within the after that you need to specify the value to an attribute definition. So the default value is included in any new tuple if an explicit value is not provided for that attribute. If no default clause is specified, so the default value null is appended for that do not have the not null constraint. Okay. Let us see with an example. Here in this case, it is a create table department. So as you can see, these three dots indicate that there are other attributes are also there in the previously there are other attributes. Instead of writing all those attributes, I have written it as triple dots. Okay. Then the manager SSN, so the data type is charnet. So I am defining it as not null. So the default value here we are defining it as 888665555. So if the manager SSN is not specified while inserting the values, so then the default value will be inserted. So the default value here we are going to insert it as 888665555. Okay. And so consider that if I have not defined the default value, so the by default value is null. So null means if I have not given, consider that instead of defining it as not null, so if I just left it as manager SSN kernel, so the default value will be null. So the third constraints we are going to discuss is about the check. So the check constraint can restrict the attribute or domain of values. So consider that if I tell that, so the engineering semester should be from 1 to 8. So I will check those whether the values will be between 1 to 8, then only I will allow to insert or to create. So that is what I am going to check whether the semesters are in the range of 1 to 8. So the check clause can also be used within the conjunction with the create domain statement. As you can see here in this case, so the D number, so the data type is integer and it is also a not null. So here I am going to check this one. So if the department number is greater than 0 and if the department is less than 21, so then only I am going to add this one. Consider that if I insert it as -1, so it will not be inserted. If I insert it as 23, so this one value is also be not taken. So only the values which are within between 1 to 20 will be considered for the department number. So the check constraint will check the domain of values. Here it is restricting the department numbers from only 1 to 20. So you can also see here, so the create domain D number as the integer check. So here also, here in this case, we are specifying it in the create domain itself. So the domain of possible values for the D number is 1 to 20. Now, after checking the constraints on the attributes, let us see the how we are going to specify the key constraint, that is a primary key. So the primary key clause specifies one or more attributes that make up the primary key of a relation. Either it can be a single column or it can be the combination of attributes, it will become the primary key. If a primary key has a single attribute, the clause can follow the attribute name directly. Or if the primary key is the has a combination of more than one attribute, then you need to specify the primary key constraints at the last. Now as you can see that example, here the department number and the int is a data type. Here I am specifying it as a primary key because D number is a single attribute. So you can specify the key constraint, that is a primary key. Whenever it has only a single attribute, you can follow, you can write that constraint, you can write the primary key right after the data type. Okay. The unique column clause specifies as the alternate key. So the unique means what is the purpose of primary key? The primary key will identify the rows within a table uniquely. So this can also be done by using the unique constraint, but the difference between the unique and the primary key is, so the unique can take the null values. Whereas if I defined it as a primary key, so the primary key will have the unique plus not null value. So that means it is simple that if I write it as primary key, so the primary key will be equals to, it is unique, which is represented as U, then also it is a not null. I'm writing it as NN. Okay. So primary key will have the two constraints. One is the uniqueness constraint, second one is the not null constraints. Here you can see here. So we are creating the table department. There are many attributes. So the manager SSR car9 not null, default value is this one. So we are defining the primary key here, that is a D number. D number is a primary. So you can specify right after the attribute data type, or you can specify the primary key also at the end. Now, after discussing about the key constraints, now let us see regarding the referential integrity constraints. That is what regarding the foreign key. So the referential integrity is specified via the foreign key clause. A referential integrity constraint can be violated when tuples are inserted or deleted, or when a foreign key or a primary key attribute value is updated or modified. That means whenever you are changing values or deleting, or whenever if you are updating or modifying the primary key or a foreign key, then the referential integrity violation will take place. So the default action that SQL takes place for an integrity violation is to reject that update operation that will cause the violation. Consider that while deleting or while updating some values, if you got the referential integrity violation, so what the SQL will directly ignore that update or delete operation. Now, as you can see that how we are going to specify the referential integrity here is, so create a table department. So here in this case, you can see that, so the referential integrity is specified by using the foreign key. We are going to use the foreign key. So we are using the column name. So that is a manager SSN. So it references. So we need to specify the table from where you are taking the manager SSN. So I am taking the values from the employee table, and which column I am referring there? I am referring to the column SSN. So here we call it as department as the referring table, whereas the employee we call it as the referenced table. So that means the department manager SSN column is taking the values from the employee tables SSN columns. So that's why the department is called as the referring table, whereas the employee is called as the referenced table. Now, as you can previously, you can see here in this case, so the constraints were giving some names. Okay, so that is what you are discussing here, giving names to the constraints. A constraint may be given to a constraint name. So following the keyword constraints, we need to give the constraint. So the names of all the constraints within a particular schema must be unique. That means there cannot be repetitions of the constraint. For example, if I write it as a constraint A, you once again can't have the constraint A in the same schema. The same schema means if you are taking the company schema, in the company schema, all the constraint names should be unique. There cannot be the repetition of the constraint names. A constraint name is used to identify a particular constraint in case of the constraint must be dropped later and replaced with the another constraint. So what is the usage of giving the constraint name? So whenever you want to drop or whenever you want to replace the constraints, then it is better to give the constraint name. So as you can see that the giving names to the constraints is an optional one. Either you can give the constraint name, or if you are not ready, even if you miss it, then it is also no problem. Now, as you can see that here I am giving the constraint name as the department manager foreign key. FK stands for foreign key. Here you can say that constraint department SK. So SK here in this case indicating as secondary key. Or you can also say that constraint department PK, that is meant so department primary key. Next, let us say the specifying the constraints on the tuples using the check constraint. So these can be called as the tuple based constraints because they apply to each tuple individually and are checked whenever a tuple is inserted or modified. So consider that I am allocating the DBMS marks. So what I am going to do, I am going to check each and individual student's attendance. If the attendance is more than 70%, then only I am going to give the assignment marks. So that means here, if the each student, if you consider it as a tuple, I am going to check individual tuple. I am going to check the individual student's attendance. Then only I am going to award the assignment mark. So in that case, then time we are going to use the tuple based constraints. So for each student, for each tuple, for each row, we are going to execute this one. Let us see with an example. Suppose that the department table is an additional attribute, that is department created date, which stores the date when the department has created. Then we could add the following check clause that at the end of the create table statement for the department table to make sure that the manager start date is later than the department creation date. Consider that your department has created on 1st August 2020. Obviously, the manager start date should be later than the created date. It can't be saying that 1st April 2020 because the department is also not ready. Then why? How come there will be a manager? So the manager start date will be always later than the department created date. So that can be specified as check. We are going to check. So the department created date should be always less than the manager started it. Now, after these constants, let us see regarding the schema change statements. So the schema change statement we have already discussed regarding the create one. So by using the create, we have created the schema. Now, if the schema is already there, so how can you going to change those schema? So for that, we are going to use two things. First one is the drop table. Second one is the alter. So the drop is used to remove a relation. So relation here in this case we are specifying it as a base table. So what is meant by the base table? So the tables which are created by using the create table statement. So those tables we are going to call it as a base table, and its definition then we are going to use the drop table statement. So the relation can no longer be used in the queries, updates or any other commands since its description is no longer exists. So for example, if I execute drop table dependent, so then once if you execute this statement, that means the dependent table will no longer exist in the description of the database. The second one is the alter table. So the alter table is used to add an attribute to one of the base relations. Consider that while creating the employee table, you have created with the 5 attributes. So after some time you feel that you need to add one more column, or if you want to delete one column, so then that time you should use the alter table statement. So that is the new attribute will have a nulls in all the tuples of the relation right after the command is executed. Hence, the normal constant is not allowed for such an attribute. For example, if I write it as alter table employee, I'm adding a column here as the job, having the data type as varchar of 12. So the database users must still enter a value for a new attribute job for each employee tuple. So this can be done by using the update command. To summarize the things what you have discussed in the today's session, we have discussed about the specifying the basic constraints in the SQL. So here specifying the attribute constraints and the attribute defaults. In that we have discussed about the so like not null, check and the unique. So those are the discuss we have discussed. Then after that we have discussed about the specifying the key constraints and also the referential integrity constraints. Then we discussed about the giving the names to the constraints. So then lastly, we have seen the specifying the constraints on the tuple by using the check. Then after that, we have discussed about the schema change statements in SQL. So the drop command is used whenever the base relation is no more wanted in your database. Then you can use the drop command. So the alter command is used whenever you want to add a column or remove a column from a base relation. Then you can use the alter command. Thank you.